Hello everyone, I'm really excited to introduce you this app that I built, GPT-4 Auto Coder and Self-Improver. So essentially we're going to get GPT-4 to write code for us and improve our existing code. How it works is we select how many processes we want to initiate in parallel. Currently it's at 10, but it can be any number. And then as we increase this, then we get other processes right here which we can define. Let's go with 4. It asks you for an idea for a Python project for process 1, or leave it blank for a random suggestion. So if you leave it blank, it will create the idea and create the code for it. So let's leave the first one blank. And let's go to the second process. Let's enter this time an idea. For the process 2, let's ask for a Python class for financial data computations. And I forgot to mention, how many iterations of improvement would you like for process 1? Let's go with 3 for this one. It's going to be a random idea, and it's going to iterate a total of 4 times in this case. The original one doesn't count. For the second process, let's go with, again, 4. And for process 3, we can ask GPT-4 to improve an existing file for us. I'm just going to select test.py. Test.py includes just a simple print hello world, and we're going to see what it makes with it. How many iterations of improvement? Let's go with 5 for this one. And for process 4, actually let's go with 4. Process 4, enter an idea again. Let's enter another idea. Let's just ask for a web scraper. Again, let's go with 4. And then all we have to do is just click generate code. Before we do that, let's open our Visual Studio Code and take a look at this experiments folder. So I'm just going to initiate this. So now it's running. So it created 4 folders: process 1, process 2, process 3, process 4. Process 3's first update has already been completed. Maybe we can just drag this here and take a look at what we're doing. It's going pretty quickly because I'm using the 3.5 Turbo for speed purposes. But let's take a look at the first one for process 3. If you remember, our first file, the file that we gave it, test.py, right here, just included a simple print statement. And then in this first update, it included a try except for catching errors. In the next one, it added a while true statement. This is nice. And the fourth one, it's even including a traceback. So it's getting pretty complicated. It's really adding a lot of stuff, actually adding error catching mechanisms. This is lovely. Let's go to process 1. I believe the process 1 was the one we left blank. Yes, we did leave it blank. So it's actually creating a to-do list with TK enter. There you go. It had created the first code, and then it had actually updated it. If you just look at here, the bird's eye view of our code, this is the first one it created. And if you click on the update, it added quite a lot of stuff. And it actually added some explanations at the end too. It needs a bit of cleaning up, but this is incredible. Here is another update. So take a look at the bird's eye view. We're going to go to the next one, and it had added more stuff. Actually turned it into a class. Was it a class before? Yes, it was. But originally, it still was a class. All right. And let's take a look at process 2. This was our financial data analyzer. Let's close this. It created a class with how to calculate the mean, median, the mode. It gave an example data and actually did some print statements. Again, take a look at the bird's eye view. We're going to look at the next one. It added quite a lot of stuff. For example, it added error catching, and it added some additional data, I believe. And in the next one, let's see, it added variance, standard deviation, coefficient of variation. And to the next one, it had, it had added some more error catching, some print statements for you to test it out with. And let's take a look at process 4. Process 3 was the test, right? Let's see what it did in the final improvement. So quite a lot of stuff. And process 4 started with a web parser, a scraper. So it started pretty simple. Then it had added to it. It included the requests. Oh, it already had it. And on the next update, it actually explains some of it said allow for dynamic URL scraping. It added function to handle scraping, finding links. Okay, scrape links. And on the fourth one, it added while true. This is an improved version. Additional error handling and improved code style, it says. Oh, sorry, I was looking at the wrong one. Anyway, right here. Beautiful soup. And the third one, updated function to better reflect its purpose. So this is lovely. And the fourth one, again, so what we can do is we can select the first file that it had generated and select the second file it had generated and right click and compare selected. And actually this left side is our first file and the right side is the second file. You can actually see some of the differences. The final version have a lot more code. Let's do it with this one as well. Right click and compare. As you can see, it had added a lot of code. So it did this all entirely automatically. We could have done this as many times as we want for any idea that we would like. So how this works is the way I set it up is that if you don't give it an idea, if you don't want to give anything, then you leave the input box blank. Then it comes up with an idea. In this case, it came up with a to-do list. We're using tk-int. And at each iteration, after you write the first code, then it feeds this code in. And there's a special prompt I came up with, which then prompts it to improve upon it and introduce error catching mechanisms and stuff like that. So this is how, and then again, the first one goes into the GPT with prompt. The second one comes out, and the second one again for the third one. And this is how iteratively we improve. As far as the selecting of files, here I have a files directory. You can put any file in here. In this case, I just put a simple one just to show you that it can really start generating some great code from a super simple statement. And the self-improvement part comes in where you can actually feed it its own code. Okay, you can do that and try to improve it. I've actually used this while I was building this project. Yeah, but any file that you have, you can put it here. And then with the user interface, you can select it by selecting improve an existing file. You can create as many processes as you like. You can, if you want, all of them can be selecting a file, any combination that you like, really. And you can go up to 10 with iterations. You can actually change this in the code. So this is really how it works in a nutshell. So I haven't started simply, and I built a total of, I believe, 9 files, which I'll make available for Patreon supporters. I also built a debugger. Now, what this debugger does is it does the same thing as the self-improvement property, but what it does is it actually runs the code and gets the error message and feeds it back to GPT-4 along with the prompt. So this has this additional feature. It's the same as everything else that you see here, but it just feeds back its own error message. So I have quite a lot of code to talk about, and I'm not going to be able to talk about it all at once, but I'm going to start with the simple one and do it for as long as I can without the video being too long. I'm also going to include this token counter using tick token. Here's a function which counts the tokens. I just put a simple code in here to be counted as a string, but you can actually load a file if you like. And in the end, it prints the token counts. So if you want to use, that's going to be included as well. So the one that I demonstrated to you is the latest one I built. I'm thinking of improving on it as the time goes on. Expect quite a lot of videos on this topic. So it uses concurrency, so it runs these processes in the parallel. It makes parallel calls to GPT-4, in this case GPT 3.5. That doesn't really matter. Wherever the model is specified, you can change it to whatever you like. But I also have as you can see, main.self-improve, which is exactly what you have witnessed, but it does it one at a time. One idea at a time or one file at a time. And I have built a Streamlit interface for it too, and also a Gradio interface. I just want to show you that real quick. This is the Gradio interface for the GPT-4 Auto Coder and Self-Improver. So you enter an idea or blank for a random suggestion. If you want to improve upon a code that you already have, you check this box and you can select from those options. You can change those options by creating a files to improve folder, and you can put any file that you like. And then you select the number of iterations. Here in this case, you can even say 100, doesn't matter. And then when you submit, then it's going to start running. But this only works one time. The iterations of improvement is how many improvements you're expecting GPT-4 to apply on a single project, that is. So this is just a sequential, one at a time approach. I also have it running in the CLI as well. This is how it works. You just run this code. So this is the parallel concurrent approach, and it asks you how many processes do you want to start. Let's say we want to start 2. Then it asks you, do you want to improve an existing file for process 1? Yes or no? We can say yes. And then it gives you a list of files. All we have to do is just select which one. For example, let's select again 3. And how many iterations of improvement would you like for process 1? We can say whatever we like. Let's just say 5. And then collecting inputs for process 2. Do you want to improve an existing file for process 2? Let's say no. Enter an idea for a Python project. You can enter whatever you like or just click enter. It'll just pick a random one for you. How many iterations of improvement? Let's say 5. And once we click, then it actually starts generating. And all the examples are going to go into this process folders. It will overwrite the file example. See, actually, no, it's actually writing the file right here. If it was in the same folder, it will overwrite it. But for other processes, it'll actually create a new file, say ex1, change to ex2. So it keeps track of that, so you can keep track of your process in this fashion. So for the random idea, I decided to create a password generator, and it had the second update already. So this is really lovely. I mean, this is incredibly useful to me, and I hope you'll find it useful as well. This is all quite a lot to talk about. I hope I'm doing this the right way, make the video enjoyable for you all. But let's start with how I came up with the idea and how I started. Let's just open the main file. So I just wanted to create a script, okay, a program, which just makes calls to GPT 3.5 or GPT-4, okay, and just creates codes and improves upon the code. So I came up with this system message. I said, you're a helpful Python coding AI who will generate code and provide suggestions for Python projects based on the user's input, or generate ideas and code if the user doesn't provide an idea. Write the code in one code block between triple backticks. Later I changed this triple backtick strategy. I'll try to outline that. So this is just in a simple function. Ask GPT-3, it should be GPT-4 actually, but you know what, we'll just leave it like that because I'll have to change other things. I forgot to change, I don't know why I did that. Anyway, so it takes in a question. Our model is GPT-4. Then we do a try and our response is coming back to us. And I'm getting the response in this fashion. This is the proper fashion, and I'm just trying to split it at where the triple ticks are, and I'm trying to get the second element of it, because it had a tendency to write a lot of stuff before the backticks, right? So I just wanted to get whatever is in between the backticks. I ran into some problems with that, but this was my first approach. Then I'm doing a try except. If I get an index error, if somehow this fails, then I'm going to make this call up to 3 times. Okay, again, for I in range 2, I'm doing this exact same process again. And I'm trying to return the response exactly as I wanted here, and I'm again checking for the same error. So if this fails 3 times, then we're just going to quit and we just say pass. We don't want to make infinite many calls. So another function is get project idea from the user input. If the user input is empty, then we actually return for as the whatever we're going to send to GPT, generate a Python project idea first. So we want it to generate the idea. We want the GPT-4 to generate the idea. And then provide a code sample, write the code in one block between triple backticks. If the user had inputted an idea, if the user input is not empty, then generate code for the Python project, and we put in the input. Again, write the code in triple code block, right? And we're just creating an experiments folder. We're just checking if that doesn't exist, we're creating it. And we have a save generated code function. First creates the experiments folder and checks for the file, because we need to have some kind of numbering, because we're going to save these under experiments folder as ex underscore, for example, 1, 2, 3, right? We're going to iterate. So this is what it's doing. We're increasing the file number, and we're doing if it exists or not. And then we're just writing the code there, and we're returning the file number because we're going to use it in the future, right? If as the code is running, we're going to increase the count. Then we have our main function. We print welcome to the Python project idea and code generator. We say while true because we want to continually be able to interact with the system. Our user input is please enter an idea for a project or leave it blank for a random suggestion. Type quit to exit. If the user enters quit to break out of the loop. GPT-3 question is get project idea user input. This is happening right here with our function. Whatever the user has inputted, we are returning the question. And then we say response is going to equal to ask GPT-3 that question, right? Ask GPT-3 is what we have defined up here. This is really the API call right there. And after that, we get a file number. Remember this file number that is being returned. And we, at the same time, save that response into the file. Then we print the generated code has been saved, whatever the file name is. Then we say number of attempts, right? So this first generates a code, whether a random idea or whatever idea you had given it. Then it asks you how many iterations of improvements would you like. So it gives you a quick chance to take a look at the file. For example, if you're generating random ideas, maybe you don't like the idea, maybe you want to restart this process, right? So you can enter however many iterations you like at this juncture, and then you get your iterations, as we've seen before. And then we say for attempt in range, whatever the number of attempts has been, then we say the question is the current code, and we put in whatever the current code is in triple backticks, and we make a new line. And then we say improve the following Python code, implement new ideas if necessary, including error catching and bug fixing. Write the improved code in one code block between triple backticks, comment about the changes you're making, and then once this is set in motion, then we say improving code, we get a response. We update the file name, we save the file, and then we say the improved code has been saved as the file name. So after writing this, I wanted to be able to work with the files that I already have. So then that's why I said main.self-improve. The reason the self-improvement came because it is improving whatever files you have, whatever code you have, right? So the code is self-improving. But on the other hand, you can give the system its own code. For example, I can, with the main.self-improve, right? We just talked about the main.py file. Or if I'm running main self-improve.py, I can actually select this file, and then it can actually make improvements on it and save it into experiments. This is pretty crazy and recursive. But let's talk quickly about the main.self-improve. I just want to say I'm going to have all these files available for my Patreon supporters. Most of the basic ones like the main, the self-improve, okay, and I believe self-improve parallel is going to be available for AI enthusiast tier. I also turned this into a class, which is so much nicer. It's so much easier to build user interfaces if you have a class. And then the parallel class, also the self.improve class, right? And then the debugger, which feeds error back into it. So the debugger and the parallel concurrent call user interface, along with its class code and the user interface codes for these, I believe will be available for the aficionado tier on my Patreon. Anyway, just take a look. I'll put all the links in the description. Okay, so let's go back to main.self-improve. So at this point, I said, this is great. I can give it an idea, and it can generate an idea and generate the code and improve upon that code. But what if I already have the file? I wanted to test that. So this is pretty much the same. Make sure to set your OpenAI key. The requirements are pretty simple. We're using vanilla OpenAI API. Again, we are doing some checking here. And actually, here I changed the prompt a little bit differently. It's almost exactly the same, except I say start a code block with a Python word. I figured that's just so much better, so much easier to actually split the text. So that was a bit of a hassle. Anyway, I print the generated text here. I get the generated text. Then I try to find the backticks, the last backtick, and I want to get everything until there because it writes a lot of stuff after the final backtick, after the code as well. And here I am also trying to find the Python, and I'm trying to get everything after the Python. There's a tendency to write Python to start the code with. So these are just some of the ways I dealt with these situations. Again, the same index error. We try up to 3 types. And then we're getting the project idea. In the same fashion, I got to update some of these. Anyway, we are creating the experiments folder. Save the code right here. File number. Okay, now here we say while true in our main loop, and we set a self-improve Boolean value to false. Okay, and then we ask the user, do you want to improve an existing file? If it says yes, if the user says yes, then we set the self-improve to true, and then we go over the files to improve folder, get them, print them, and then print them on the terminal, and then we ask the user which one do you want to pick. The user responds with whatever number. Then I actually print the first 100 characters of the response, the file. I'm not sure, maybe I made a mistake here. Anyway, just for information purposes, we set the file prefix. But if the user said no, that means we're not going to do self-improvement. We're not going to work with a file. Then we just go back to what we talked about. Please enter an idea or leave it blank, random suggestion, right? And the rest of the code is pretty self-explanatory, right? If not self-improve, then we do the thing we need to do. If it is self-improve, then we ask how many times you want to work on this. And we run it for that many times. And for the rest of it, we again ask if it's not a file, if it's not self-improvement, then we ask for how many iterations that you want on the idea or whatever your idea was that you inputted. And then we do the GPT calls right here. Sorry that I forgot this GPT-3. This is for chat completions anyway. You can you totally use it with GPT-4. It's going to be slow and it's going to cost a lot of tokens. You can use GPT 3.5 Turbo as well. Okay, so that's about it. So I have the main.py file, which gets the idea or your idea or generates an idea. Self-improve, which on top of it can accept a file. Self-improve parallelizes that process, so you can run as many ideas at the same time as you like. I have turned the self-improve into a class, also the parallelization into a class, and I have built a user interface for the self-improve, both in Streamlit and Gradio, and I have also built the Streamlit for the concurrent parallel calls to GPT-4. Anyway, I hope you enjoyed this. This is really something for me. It took a lot of my time. I hope you enjoyed it, and I hope you'll make good use of it. I'm going to be making more videos about this. I'm going to go over the code in the future videos. So this is just a lot of code, honestly. But we're going to talk about it all in due time. And thank you for watching.